Algebra 2 math geniuses. Good to talk to you guys the other day, and it's good to get your first lesson started for today. Now, please get out your pens, pencils, calculators, and take some really good notes today. And let's go ahead and get started. In this video, we'll be looking at pretty much stuff that you have had in the past, okay? Like most opening lessons in a chapter, it's pretty easy material, but be thankful for that. Don't complain, because the material will be getting more difficult as we progress throughout the book. We are going to study today 3 definitions of different types of numbers, 6 properties, and 4 operation terms. Now, please don't pass out listening to what I just said. This will not take long, and I believe you will find it very easy. Your heading for today is, please copy this in your notes, real numbers and number operations, lesson 1.1. I would also encourage you to copy the date today, to copy down today's date. I never give you the date because these videos are going to be used year after year. So whatever today's date is, go ahead and copy that down. And then we'll get started. So I'll give you a couple more seconds. Real numbers and number operations, lesson 1.1, and be sure and include today's date. If I go too fast, just simply pause the video. Here we go. Now, throughout the year, we'll be using terms like real numbers, imaginary numbers, rational numbers, irrational numbers. By the way, you do not need to write this down, okay? Now you can if you want to, but you don't need to. Complex numbers, integers, whole numbers, etc. Okay? It is really important that you know what set of numbers I am referring to when I use a certain term. Now, today's material is in no way, in my opinion, difficult to learn, but it's rather quite easy. However, it is a little boring. However, it is very important. Now, let me stop and say this. If you're used to geometry, you know you had to do so much of what last year? Memorizing, correct? Remember that. And so I don't want you to think, oh great, Mr. Earhart is a big term person. That is just not true. I am a big math person, okay? And I do not like definitions, properties, memorizing. I love working and solving problems. However, just like any class, we have to have some terms we have to go over. Alright? So let's go ahead and continue on. But it's very important you understand what we look at today. By the way, I told you we're going to look at 3 definitions of different types of numbers. Just 3. So we're not going to look at all of these today, okay? I was just listing out different terms we're going to use throughout the year. Now, today I want to start off by looking at these terms. Real numbers, whole numbers, and integers. I would not write that down yet because in a second we're going to write these down with their definitions, okay? Alright, now, let me say this. Because the entire premise of geometry is based on definitions, postulates, corollaries, theorems, etc. You had to memorize those, and I made you memorize those, and we did fill in the blanks on the test and quiz. You remember that, I'm sure. You probably still have nightmares from that, okay? I'm not going to make you memorize these terms and definitions. However, I will ask you on a test or a quiz to give me examples of these or to recognize these if we have a group of numbers given to you in a list. I would want you to tell me which one are real numbers, which one are whole numbers, which ones are integers, etc., etc. So you do not have to memorize the definition, but you have to know it well enough to recognize the different types of numbers. Having said that, I do want this in your notes, so please copy this down. Real numbers. This is so deep. Yes, I'm being sarcastic. Any number that exists on a number line. The only number that is not a real number is an imaginary number. It's like one of those duh moments, of course. I mean, if it's not real, it's imaginary, okay? So, any number that exists on a number line is a real number. Now, imaginary numbers do not exist on a number line. That's why I can give this definition right here. Any number that exists on a number line is a real number, okay? Now this part here you can write down if you want to. You don't necessarily have to, that's up to you. Now here's a number line. Think of all the numbers that exist. You have 1, you would have 1.2. You would have, over here, you would have 2 and 3/4. You would have negative 1 and 1/8. You would have negative 3 over here. Any number on the number line is a real number. That's it. Pretty simple. So, Mr. Earhart, you're basically saying any number is a real number. That's correct, as long as it is not an imaginary number. By the way, we will talk about imaginary numbers later in our study of algebra. Okay? Alright. And you've had this stuff in the past. I know that you guys have. Okay, copy this in your notes, please. Integers. An integer, is any number that exists on a number line that is not a fraction, decimal, or irrational. Okay? I'll give you a second to copy that down. We're going to move on. And remember, if I go too fast, pause the video. Any number that exists on a number line that is not a fraction, it is not a decimal, or irrational, it is an integer. Alright? So with that in mind, let me pause here and make a comment about rational and irrational numbers. Then I'm going to go back and give you examples of integers, okay? Don't worry about these two words right now. If you've studied rational and irrational numbers in the past, sometimes, depending on how it was taught, it can be pretty confusing. Not always, but sometimes. If you found studying the difference between rational and irrational difficult, no sweat. Don't worry about it. We're going to look at these later. They'll be explained later, and you'll totally understand it, okay? But for now, I'm not worried about that. So let's focus our definition on any number that exists that is not a fraction or decimal, okay? And really, well, I won't get into that now. So let me give you some examples of integers, okay? An integer could be 0. It could be 1. It could be 2. It could be 3. It could be negative 1. It could be negative 2. It could be negative 3. Negative 4. But it could not be negative 1.2 or negative 2.5 or 1.3 or 2.9. It's any whole number, positive and negative, including the number 0. All of these are integers, and of course, it continues on to the right and it continues on to the left. Isn't that easy? Let's review. A real number is any number on the number line. So integers, all integers are real numbers, but not all real numbers are integers. Let me say that again. You might want to copy that down. All integers are real numbers because 4 is on a number line, so it's a real number. Now, 4.5, is that a real number? Yes, because it's a number that exists on a number line. However, is 4.5 an integer? No, it is not, because it is not a whole number, positive or negative or 0. Okay? Alright, hope that makes sense. I'm going too fast, pause the video. Now let's talk about whole numbers. Copy this definition down, please. A whole number is the number 0 and all positive integers, okay? The number 0 and all positive integers. Keyword integers, okay? So here's a number line. Here's 0. Here's negative 1. Here's a positive 1. Positive 2. We'll go negative 2. And how much notes you take is up to you, okay? I do want you to copy this in your notes right here. But if you understand this without my examples, that's fine, okay? That's up to you, how many notes or how much notes you take. I would encourage you to take as much as possible, but that's up to you. Now, whole numbers they include the number 0, so put a check mark here, and all positive integers. So 1 would be a whole number, 2 would be a whole number. These are not whole numbers. Now back here when I describe integers, I very carefully said it's all whole numbers. Then I said positive and negative. I said negative numbers, okay? So that's why I said it that way. But a true whole number in mathematics does not include negative numbers at all, period. Whole numbers would be 0, 1, 2, 3, 4, 5, 6, etc. It would not include 1.5, 2.3, 4.1, because those are decimals. It has to be integers, and they have to be positive. And then also we include 0. Don't forget, students, 0 is neither positive or negative. It's the boundary that divides your positive and negative numbers. But 0 is neither positive or negative, okay? So, I hope this is making sense. Take some great notes. Let's continue on. Now, let's look at some properties that you'll be responsible for. When I say responsible, it's just like these definitions here. I'm not saying that you have to memorize them, but know them well enough. These properties that I'm about ready to show you, know them well enough so that you can answer questions about them during during a test or a quiz, okay? And I will quiz you and I will test you in a very challenging manner. I will try to trick you, not for the sake of tricking you, but so that you will prove to me that you really understand the math. Now go ahead and turn your books to page 4, okay? If you want to, you don't have to. This is what you'll find right there. In fact, maybe you don't want to turn there, just in your notes. Make a note that the properties we're going to study right now are on page 4. You could write that in your notes. I would write this in your notes personally. I would write properties of addition and multiplication. Then I would put in parentheses right here beside that, I'd put page 4, okay? There we go. That's how I would do it, okay? I'll give you a second to copy that down. Properties of addition and multiplication, page 4. I would not copy all this down. That's why it's in your book. That's why we're making reference to it being in your book. There's no need to waste time, okay? So, having said that, here we go. Copy this down, please. Properties of addition and multiplication. Put page 4. Now let's talk about these properties, okay? Now my suggestion to you is to write examples down that I'm going to give you. Okay, for example, in your notes, I would write the word closure. Okay, like we have here. And I would put 1 plus 2 equals a real number. And this is another duh moment. Also, I would put 1, look right here, guys. Do you see 1 plus 2? So I put, or a plus b, I put 1 plus 2. Do you see a times b? So an example of closure would be 1 times 2 equals a what? Real number. So what is the premise of closure? To me, it's really a waste of time, but we'll teach it. It's in the book, that's fine. It's saying if you add 2 real numbers, you'll get out a real number. I mean, that's just obvious. If you multiply 2 real numbers, you get out a real number. That really is obvious, okay? Let's continue on to number 2. So in your notes now, I would simply write commutative now. Now again, you take notes how you want to. You know best how you learn, okay? But I'm making suggestions. You copy this down. Now, obviously here, a plus b equals b plus a. So I'd simply say 1 plus 2 equals 2 plus 1. That's all that closure is. So on a test or a quiz, I would give you an example. It might be matching. It might be fill in the blank. It might be multiple choice. I would write this for an example, and you would have to write the word commutative, or I might give the word commutative, and you have to give me an example. Okay? Now we have addition, properties, and multiplication. So now another one would be 1 times 2 equals 2 times 1. That's called the commutative property, okay? If I'm going too fast, pause the video. I'm going to continue on, okay? Here we go. Now before I get to number 3, associative, and you can write that down if you want. Before I start talking about it, I have a question for you. If I have 1 plus 2 plus 3, isn't that the same thing as 3 plus 2 plus 1? Sure it is. Or 1 plus 3 plus 2. Sure. Or 2 plus 1 plus 3. Okay, Mr. Arrow, we get the point. Okay, so if it's all adding and nothing else, can you not write them in any order? Sure you can. Well, that's what they're saying here. If you have two numbers grouped together, 1 plus 2 in parentheses, like this right here, then plus C another number. By the way, how do I know A, B, and C are numbers? Right here, guys, look. Let A, B, and C be real numbers. Okay. Alright. 1 plus 2 plus 3 equals, now look, A's right here, so 1, and then plus B plus C, so 2 plus 3. So all that I did is I picked up this parentheses right here, and I moved it to right here. And I picked up this parentheses here, and I moved it to right here. Now, look, of course they're equal, because here you're saying add the 1 and the 2 first, and then add 3. Over here you're saying add the 2 and the 3 first, and add the 1. Well, guys, I just reminded you that 1 plus 2 plus 3 is the same thing as 3 plus 2 plus 1, or, sorry about my handwriting, or plus 1 plus 2 plus 3. If it's all addition, it doesn't matter what order you add them, so of course this is true. Okay, same thing with the multiplication. If you have 1 times 2 times 3, and that's a very poor job, sorry, I apologize. It should look like this right here. A, B in parentheses, then C. So A, B in parentheses, 1 times 2, and then times C, equals, now we'll put BC in parentheses, so a 1 here, then parentheses, then 2 times 3. Of course they're equal. Look, if you have three numbers being multiplied together, 1 times 2 times 3, 1 times 2 times 3, it doesn't matter what order you multiply them in, okay? You could have 1 times 3 times 2. So this is called the associative property, okay? It's telling you can move the parentheses around in certain scenarios, okay? Now let's talk about the identity property, okay? The identity property right here. Now, the basis of the identity property is this. Go ahead and write down the word identity in your notes. The basis, students, is this. The basis is whenever you take a real number and add something to it, you should get out the number you started with, okay? So, if I have 5, what would I have to add to that to end up with 5 again? Well, for the third time this lesson, another dumb moment. I mean, look, the only number you could put there would be what? 0, right? I mean, 5 plus 1 is 6. Whatever number I start off with here, I want to end with over here. So it has to be 5 plus 0. So any number plus 0 equals the same number. We call that the identity number. Now, I'm not the most brilliant teacher in the world. I kind of struggle with this right here because I've taught pre-cal. I've had calculus 1, 2, 3. I've had 12 hours of calculus. This really, to me, I mean, I guess the identity property is just turned around, but usually I see it written in this order here, personally, but either way is fine. Be able to recognize both of these orders. 0 plus 5 equals 5, okay? Now, same thing with multiplication. If I have the number 5, what would I multiply it by to get out the number I started with? 1, not 0. 5 times 0 is 0, okay? 1. So that's an example of identity property. You start off with 5 and you ended with 5. You can also turn that around according to them. Now, I'm not a big fan of that, but that's fine. 1 times 5 equals 5. So these are examples of the identity property. The identity property. Okay? Alright. Now, continuing on. For you, 2 or 3 students that are still awake, here we go. Inverse property. Now, and again, I don't think this material is difficult at all, but it's boring probably, but it takes memorization. You have to learn this stuff, okay? Now, when you're dealing with addition, are you listening? Listen carefully. When you're dealing with addition, the inverse property is when you add two numbers together and get out what? 0. Now, don't get confused. The identity is when you add two numbers and you get out what you started with, or in multiplication, you get out what you started with. A times 1 equals equals A. That's not the case with inverse. Inverse addition property is when you add two numbers together and get out 0. So that would be 5 plus negative 5. That would give you 0. Another example, 3 plus a negative 3. That would be an example of the addition property, the inverse addition property. Now the inverse multiplication property, notice you want to multiply two numbers. Not that you get out 0. Look, you get out 1. Are you seeing the difference here? In the inverse addition property, you want to add two numbers so that you get out 0. In the inverse multiplication property, you want to multiply two numbers so that you get out 1. So if you had 2/3, if you flip that, you would get 3/2. That would be an example of the inverse property. If you have 5 and you flip 5, 5 is really over what? 1. So if you flip 5 over 1, you get 1/5. So 5 times 1/5 would give you 1. If you had negative 1/2, or negative 1. Well, I've got a 2 now, 2/5. Negative 2/5 times negative, and then flip it 5/2, you'll get out 1. So all of these numbers represent the inverse multiplication property. By the way, you've used the word inverse before, have you not? If I said, students, what's the inverse of 2/3? You would say 3/2. And that's why we use the word inverse when dealing with fractions and stuff like that. Okay, all right, almost finished. I am not going to give you examples of these. Well, you know what? I will very quickly, and I mean very quickly, so right quickly. I'm just going to call it distributive property. I'm not going to worry about left and right. Okay, the bottom line is this. Actually, I will give you an example of the left, an example of the right. Okay, all right, distributive property. A times B plus C, that's like having 2 times x plus 3. You should have learned that in algebra. 1. Multiply your 2 through 2 times x is 2x. 2 times 3 is 6. And some of you had Miss Calver, some of you had Miss Walker. That should look familiar, okay? Take the 2 and you multiply it through. That's the distributive property. Or this 2 right here. See this 2? That 2 can also be on this side of the parentheses right here. And so let's go ahead and take a look at that. If you had a parentheses x plus 3 like this, and then a 2 right here, that would equal, well, take the 2 and multiply it through. 2 times x is 2x. 2 times 3 is 6. Now if that's confusing, don't worry. We're going to go over all of this when we get into similar terms. Okay, you're fine, but just understand these examples, okay? Distribution is when you're taking a number and multiplying it through. Okay, all right, we got to pick up the pace here and try to finish this in about 5 more minutes. Next, let's review what the words sum, difference, product, and quotient mean. Now this goes back to elementary, so I'm going to go really fast. Now, if you've never heard of these words, do not be embarrassed. Don't feel dumb. Take good notes. But most of you have had this in the past, if not all of you. And the reason I want to finish this quickly is so that you have time to work on your homework today. So here we go. And that should not be there. Okay, my fault. Sorry guys. Old age is setting in. Alright, here we go. So, sum means to do what to two numbers. Write this down, please. Actually, if you don't want to write this down, you don't have to. If you know this pretty well, don't worry about it. What does difference mean to do to two numbers? You subtract them. What does the product mean? When I say find the product of two numbers, what does that mean you're doing to them? Multiplying. If I said to find the quotient of two numbers, what are you doing to those two numbers? Dividing them. I'm going to move on. Okay, write that quickly. Pause the video if I'm going too fast. Sum means to add, difference means to subtract, product means to multiply, quotient means to divide. Lastly, but quickly, let's apply what we've learned to some numbers, and then we'll be done with the video. Okay, here we go. Now, I want you to plot these numbers in a number line and then write them in ascending order. Ascending means going up. You cannot go up unless you start with the largest number. No, you must start with the smallest number so that you can go then what direction? Up. If I ask you to write the numbers in descending order, that means you're going down, and you cannot go down unless you start with the largest number and work your way down. Got it? So I want you to take these numbers and write them in ascending order going up. Now, a lot of you notes. Square roots, the best thing to do if you struggle with this is put them all in decimal form. That really is the best thing to do. So with your calculator, I would take 2 divided by 3, and you'll get 0.6 repeating. So negative 2/3 is negative 0.6 repeating. Now with your calculators, type in the square root of 2, and you'll get out 1.41 rounded. Now with your calculator, type in 5 divided by 2, and you'll get 2.5. Now that really makes it a lot easier when it comes to writing them in ascending order. So here's a number line. I would like you to put them on a number line. So 0, and you do not have to be perfect. I'm just going to go over here and put a line, put a point, and put negative 0.6. It does not have to be drawn to scale. It doesn't matter. Just come over here and put 1.41. Next on a number line would be 2.5. So if I asked you to write them in ascending order, that means you're going to go up. You must start with the smallest. Well, on a number line, the number furthest to the left is the smallest. So now I would like to be a stickler on this. Do not put 0.6. I want you to put the original numbers you started with, okay? So it might help you to put the original number above these decimals, okay? Because that's how I want your answer to be written. So the number furthest to the left is negative 2/3. The number that comes next is square root of 2. And the number that comes next is 5/2. So there, we did it. And they already happen to be in ascending order, which is fine. But you wrote the numbers in ascending order. Okay, moving on. Now, I want you to use inequality symbols to compare these two numbers. I want you to do it 2 different ways. Hey, you're smart students. You probably don't need to do this, but it's my job. You probably don't need to use a number line is what I'm saying, but it's my job to teach this so that no student is confused. So I'm going to put a 0, then a negative 4, and then over here a negative 7. Okay, that way you're seeing which number's further to the left, negative 7, which number's further to the right, negative 4. So now we know this is the smallest of the 2 numbers, and this is the largest of the 2 numbers. So I want you to write these 2 numbers how many ways? 2, using what? Inequality symbols. Got it? So here we go. If I put negative 7 first, negative 7 is smaller, so I would say negative 7 is smaller than negative 4. There's one way to do it. Or you can put the negative 4 first. So you would say negative 4 is greater than what? Negative 7. There you go. You wrote these 2 numbers how many different ways? 2, by using what? Inequality symbols. Negative 7 is less than negative 4. Negative 4 is greater than negative 7. Now some of you might have thought for a second, oh wait, 7's bigger. Negative 7's greater than negative 4. And that's incorrect. That's why I put these on a number line for you to see. And some of you are sitting there right now being bored out of your mind, but others are sitting there being thankful that I did this because it helps them see it. So everyone learns differently, okay? So you do not have to do this if you don't want to. But if it helps you, then do this so you get a picture of it. Alright, moving on. Find the sum of 12 and 14. Negative 12. Well, guys, look, I mean, you've got calculators. Now, if I had you in Algebra 1, nobody would use a calculator for the first 9 weeks or something like that. I would drill your sign numbers. But you're in Algebra 2, so we're not going to worry about that, okay? So, sum means add. So with your calculator, you type negative 12 plus 14, and you'll get 2. And by the way, most of you don't need a calculator for that. What am I going over here that sum means to add? Copy this in your notes. The difference of 2 numbers. Now difference is important that you go in the right order. So 5 comes first. Then difference means what? Be careful. Minus. Then what type of 13 do I have? Minus 13. Now if you don't want to put the parentheses, that's fine. If you want to write it like this, I don't mind that. Just be careful. So with your calculator, you would type in 5 minus a negative 13. Okay? And the answer you'll get out is 18. I'm not going to go over how to do this. That's Algebra 1. You can use a calculator if you're not very good with your sign numbers. I will say this, a negative makes a positive, so you really have 5 plus 13, okay, which gives you 18. But use your calculator if you need to. The main thing I want you to remember is difference means subtract. the product of negative 3 and negative 11. Product means multiply, so I have negative 3 times negative 11. Well, use your calculator. A negative times a negative is positive. 3 times 3 is, or 3 times 11 is 33. Okay? Alright, moving on. Quotient means divide, so you could write it like this. Negative 42 over 14, that means divide. Or you could write negative 42 divided by 14. Either way, you get out the same answer. A negative divided by a positive is negative. 42 divided by 14 is 3. So your answer is negative 3. Okay? Alright guys, like I said, when I say suck up, I'm saying to take advantage of or suck up all of this easy material. Get your average high, because the more difficult material will be coming, and it will be coming pretty quickly. So enjoy the stuff that's decently easy, okay? I hope this has made sense. If you have any questions, don't hesitate to call or email.